We often picture the race for artificial intelligence as an endless stream of code and data, fought entirely on server backends and computer screens. The leading tech giants already have the mathematical models mapped out for the next massive leap in machine reasoning. The software is ready, but they are running out of the raw electricity and the physical components required to turn those advanced models on. This is the $10 trillion bottleneck, the estimated global cost of the infrastructure needed to bypass the unyielding physical engineering constraints of current hardware. The artificial intelligence revolution is locked in a fight against the immutable laws of physical thermodynamics. This is a raw silicon wafer. Massive AI computation pulls an unsustainable energy drain through this material, pushing the hardware to its absolute melting point. Zoom into the microscopic level to encounter electron migration. Forcing too much power through a traditional circuit acts like a river physically scraping away the wire's inner walls. Scaling up electricity only accelerates this friction. The heat builds until the wire fractures and snaps. You cannot fix melted metal pins with a software patch. Bypassing this bottleneck requires an entirely new foundation of physical materials. To maintain the current pace of AI development, engineers have to reinvent computing on two entirely different scales at the exact same time: the microscopic chip and the massive warehouse. At the atomic level, scientists are testing highly exotic materials to replace silicon and survive the extreme thermal output of AI. One leading candidate relies on diamond substrates. Labs are engineering synthetic diamonds to act as ultimate microscopic heat sinks. Because of its highly structured mechanical lattice, a diamond substrate pulls immense heat away from a processor almost instantly, whereas standard silicon traps it. Other facilities are testing a more radical alternative called optical computing. This architecture ditches electrons entirely and uses light to process information. Computing with light completely eliminates physical electrical friction. Without that friction, the baseline heat output of the chip plummets. Engineers are also heavily testing advanced glass microchips as another structural replacement to bypass the limitations of a standard circuit board. These microscopic solutions redefine what a computer is made of, pushing material science to its absolute edge to keep up with software. Stepping back out to this modern data center aisle reveals the macro scale of the problem. A single exotic chip means nothing if the entire building self-destructs from ambient heat. When you rack tens of thousands of advanced processors together into an AI hypercluster, they generate enough heat to melt the surrounding infrastructure. Standard industrial HVAC systems and air cooling fans are completely obsolete against this level of concentrated thermal output. To prevent catastrophic hardware failure, open-loop zero-chemical cooling has shifted from a specialized luxury to an absolute necessity. For the most extreme thermal loads, engineers deploy immersion cooling, submerging entire running servers into specialized, non-conductive liquids to pull the heat away directly. Modern data centers have transitioned into massive, complex thermal management plants, where the primary design challenge is liquid circulation, not rack layout. The current stage of AI development is an era of heavy industrial manufacturing. Generating intelligent code is now relatively cheap, but dissipating the resulting physical heat is exorbitantly expensive. Tech giants now function as vast infrastructure and energy management firms to support their digital products. Between the cost of specialized materials and the massive power grid upgrades required to feed these clusters, the total bill for the AI revolution is projected to hit $10 trillion. This bottleneck is shifting capital away from app development and pouring it directly into fundamental physics and material sciences. Market dominance now belongs to the company that masters the physical science required to stop their machines from melting into slag.